Right. Okay. Last few, well, nearly an hour. Not really. Keep it short. So last few minutes. So now let's get to something else. So we looked at unit testing. We did the mocking thing, so we can isolate certain tests and concentrate the units, even if they invoke external entities. Pretty handy. The idea is now, okay, let's move from primarily backend kind of testing, web services, databases, any of that kind of stuff, services in the widest sense that you would invoke, to the front end, right? So how do you actually test GUI, right? So did any one of you try it already, testing GUIs in Android? No? Lucky you. Because testing GUIs is probably one of the more hard things in Android. Why is that probably the case?
It's hard to simulate the user input realistically.
That's part of it, yes. So there's that one. Realistically is a very good point, right? So because you may think how the user behaves, but you don't know how the user behaves. It's a very good point, yeah.
Varying hardware types.
That's correct, right? So what can vary?
The screen size, the resolution, sensitivity of the screen. It's produced with cheap parts.
Yeah, exactly. Right. So there's quite a bit of diversity in the Android world anyway, right? So screen size orientation. Yep. Cool. Yeah. What else? Anything else? I think that covers the most parts of it. Well, third part I would want to add is that I think the UI is the most frequently changed element or component across Android versions, right? The backend, the whole concept of application components like activities, services, broadcast receivers, content resolvers, all that providers, all that stuff is really since Android 1, right? But the GUI has changed massively, right? So new concepts have been added. Many concepts have been deprecated, so you can still use them, but you're discouraged from using them, and they suddenly stop working, right? So and then it boils down to the manufacturer's choice of how you implement certain things, even though the API may be the same, certain things just don't work the same way. So there's that, certainly. How can you have a kind of reasonably general approach to testing of GUIs is the other one. So, and for Android, the go-to framework, similar for mocking Mockito, it's Espresso for GUI testing in Android, right? You find this in the API documentation as well in Android. They point to Espresso as the framework for doing GUI testing in principle, right? So it combines it again with other frameworks. It always sits on top of JUnit. So if you don't know about JUnit, you kind of have an issue, right? So because that's the prerequisite for thinking about Espresso. It's a standard tool pretty much. And what it provides you is, again, as all test frameworks, now you realize that it's usually two things. You need to simulate activity and then you need to validate activity, right? So, and particular here for GUI frameworks, we are a bit more on the driver side on things in a way, right? That we're emulating robotic behavior by a user, competent or not so competent user anyway, the direct interaction via the user interface, right? So slightly different from Mockito, where you're usually expecting input. Here we're producing input and expecting output. So quite the opposite. Here, the links are of course in the slide set. So if you want to get more detailed overview of Espresso, that's the pathway to go. But I just want to give you an intuition of how it actually works. So what it in principle does, Espresso it specs the UI specification directly, and it can, for example, identify views, buttons. Oh, buttons are views in a way as well. So any view pretty much, and can emulate certain behavior such as pressing back a button or opening or closing the soft keyboard, which is something that's kind of implicit, right? If you have a text entry field and you wait for a few seconds, I guess, or milliseconds, then suddenly the soft keyboard comes up. But with Espresso, you can explicitly control that, or suppress the use and so on. In addition to actually accessing particular views, you can match them as well. So for example, if you have a view that has a certain ID, you can match it on ID. Think about looking at the UI, at the XML layout specification for the user interface for activities in Android. That's roughly what Espresso sees, right? It knows the identifier and then can do certain actions on it and see what's in there, right? So if you don't know the identifier, give me all the items or all the entry fields that have a certain text. You can match on text, right, or data, things like that, right? So that's the idea. So there's matching facilities, and then of course the action facilities, things like perform certain actions, like clicks, for example, right? Commonly clicks. Okay. And then of course, anytime you do something, you also need to access it, and that's usually the check statement again, right? So in JUnit, what are the usual statements for doing validation? Assert statements, right? In Mockito? Verify, right? And here it's like this check statement, right? So there's also one way of figuring out, of course you can see it from the imports, but sometimes it's just prepping you for that one. If you write reasonably complex tests, sometimes pretty hard to figure out, okay, what was it now? What am I actually interacting with? Is it the mocking framework or the actual normal JUnit, or actually am I in Espresso, right? Because it's quite important. And that's another, I'll probably get to that when I show you the code. Another gotcha. So how does it work? Example down here, very simple, straightforward. So the idea is that given a particular view, and the view is here matched with ID, right? So with ID, RID my view. So that's, for example, identification of, what must it be? It must be a button, most likely. So it matches a view with this identifier my underscore view. And then it can do certain stuff on it. Well, perform, and then the action is click. Perform a click, press the button. Right? And then it changes the validation as well. So it says check that it's actually displayed, right? So if you press a button and check that something is displayed there. But basically that's the DSL for this one, right? You select the view, we do something, you validate the outcome. That's the kind of straightforward idea. So not much magic there. Here we have it as well. You don't always need to do the validation, of course. You can just perform sequential actions and then do a validation at the end, similar to what we saw before for the other examples. So the validation is only sensible when you actually feel that it's makes sense, right? So here, for example, take a field of identifier, perform a certain input. For example, here the action is to type text, Steve, and then afterwards, find the read button using identifier and click this thing. And then you want to do a match, basically. Well, you're looking for a view, so yet another display element, or layout element, rather, that matches Hello Steve. So you're expecting some output somewhere, but you're not quite sure which element it is, possible, right? So you just match on the text, and then check whether that's actually displayed, right? Whether it's actually shown and you can see it. So that's the idea there. So quite an analogy to the Mockito kind of language in a way. But here more for displays and centered around the idea of views. All right, let me excite you first for a bit. So last session I showed you already here this very simple calculator thing, quite straightforward, which is an example of how to separate functionality from GUI already for the sake of unit testing. I'm not sure if I mentioned that last time, but the idea is here, okay, you have this calculator thing here, right? So then you can enter stuff and it hopefully does something. I'll try that again, see if it still works or not, who knows. Go away, and then add this thing, yeah, 35. It's probably about right. Anyway, so, okay, now assume you have this thing here, the calculator. So, and of course, it's separated in two functionalities. On the one hand, you have the actual core calculator, which does what it's supposed to do, adding stuff and subtracting stuff, so it's the only thing it actually supports. And then you have the main activity, which is nothing but the layout, basically. It holds a reference to the edit text views, to the buttons, and the text view that serves as output. Kind of here binds those one on create. So we actually have access to those fields, and there's some button listeners that perform certain operations, when the button is clicked. That's it. So basically the idea is here, and when there's output, then it shows the response of those operations in the output field. So it's a kind of a very neat and clear separation of the UI and so on. And for the unit tests, what you then can specify is you don't need to worry about the UI, right? So here we separated UI from actual calculator functionality. So in the setup here in JUnit, you basically have a before annotated method, which can be of any name, as long as the annotation is before. Instantiate a calculator, field is here, field declaration, and then you perform certain tasks, right? For example, calculator add 2 plus 2, and then you do basically the assert statement. So classical JUnit stuff, you check that 2 plus 2 equals roughly 4, right? So, and hopefully it works out. That's the idea, and you print a message. By the way, if you do JUnit, right, they usually have different method signatures. I mentioned that before. It doesn't do it nicely here. But that either allow you just to provide the actual result, the expected result, but alternatively also allow you to specify a string that is kind of a message equivalent of what went wrong, right? So it's quite helpful for debugging, especially, I promise you, if you have large number of tests, right? Makes it a lot easier. Cool. So that's the JUnit test. That thing will run, no big deal. So just to know what's happening there and how the application is roughly structured. And it probably runs something. Yeah, cool. All good, all done, no magic there. So let's look into the actual more interesting tests, of course, the instrumentation tests. And here's where Espresso comes into play. How do you get Espresso into the pool? Well, first of all, get rid of unnecessary stuff because there's no mock in there. So you import Espresso, right? It's generally Android support test Espresso. And Espresso comes with, of course, all that static imports that you can use as part of the DSL. That's how the language is basically modeled, right? By chaining different static methods, right? For example, here on view, click, type, matches. So that's kind of for matching text, for example, or for matching certain things with ID, with text, matching on particular text. JUnit's assert is here. There's still some Mockito stuff in there. I'm not sure why I left that in there. So that's basically roughly the idea. And how does it work? Well, the only thing you kind of need to, we need Mockito for a bit. We need to mock the context. Recall that no, we don't need to, that was for different tests. Ignore that one. We don't need to mock context because we are only simply accessing the UI, sorry. Okay, so first of all, here's the test specification. So I just called it type operands and perform operation. So what does it do? Well, you basically say on view, identify the view with a unique identifier. That's the text field value 1. And then perform, well, type a text in there, 16, whatever. And the second one, type 16 as well. And then close the soft keyboard and then basically perform click. So here it comes. In terms of interaction and UI, you kind of want to see what your robot does, because sometimes it's doing stuff you don't quite expect. So when writing this very simple test, just a simple test, the test will inherently fail until you actually manually close the soft keyboard. Yeah, if you forget to do that and you try to have it click, nevertheless, the test will fail, and there will be no indication as to what went wrong. So you kind of really need to see and inspect what the interface does before you can assess whether it actually finds what it finds the buttons and it presses the right buttons and so on. So it's a lot more tricky, more kind of nearly subjective in a way, and depending on the runtime environment. So for example, the timing with closing a soft keyboard may not be fast enough to actually be successfully completed before you perform the click. So there may be concurrency aspects as well playing into it when you run this. So basically what this one here does, basically get those two values, perform a click on the add button, and just check that the output matches that particular text, right? So relatively straightforward idea here. And that's the only thing that I want to give as inspiration for now, because Mockito will continue to, Espresso will see it in a bit again, but just to give an impression of how it works. So it brings up the application, hopefully. Let's see if the demo effect works out as usual, or not. Patience. We get there. I actually runs two tests, right? It instantiates the context. Don't worry about this. This is a random from old tests that I tried out and abandoned. So basically, it types of stuff. You see how it closes the soft keyboard and then basically press the add button, gets the right result, right? So that works basically. If I remove this Espresso soft keyboard, let's see what actually happens, because I haven't tested that without on the. I haven't tested it yet without it on the API 28 VM. Perhaps that looks slightly different. Perhaps it actually works even without closing. So that's the thing, right? So we really need to test on if you change the virtual machine, it kind of is a bit tied to it to some extent, or at least a bit tighter than conventional unit tests only that don't rely on this extension. First value, second value. Right. So what happened? So literally, it shows an error. Let's see if we get something meaningful out of it. It probably couldn't find a button. Right. So perform exception. Error performing send down motion event, so basically clicking event, on view unknown. So it couldn't find the view. Right? So that's the evident message here that we get. So nice. It's actually quite explicit. See, single click at coordinates with certain precision. Quite nice. So there's an exception there. So they actually tried to it figured out the coordinates of the buttons, but the keyboard was there. So it pressed the keyboard, so meaning the actual test wasn't invoked, right? So from the specification, it figures out the right dimension, but it just wasn't in the foreground, right? So that's one of the things. That is kind of, it's not explicit, right? You wouldn't know. You need to debug and play around with this until you find those things out. So UI tests can be kind of a bit annoying sometimes to deal with. So if you do them, really don't think about writing the whole test, do it incrementally. Really like simple things, pressing a button, getting to the next stage. Otherwise, it's really hard sometimes to figure out what went wrong and where it went wrong, right? So, so much about Espresso. I don't want to go too much deeper in it because we'll see it back in a second for in conjunction with another tool set. So you see how things stack up, right? So we have JUnit, we have Mockito, then potentially on top of it Espresso and so on. And all the tools kind of relate to each other in that they have an own DSL for slightly different purposes. So of course, this is only a very simple form of interaction. You can imagine because the hang on. Because we dealt with UIs right now, we didn't consider how it, for example, interacts with web views and so on. How you interact with spinners, lists, and things like this. How do you select items there, right? So it's quite involved. So there's various so-called Espresso recipes, right, that you can explore. It's linked, of course, as part of the slide set, where you can see how we can actually match different things, right? For example, action bars as well. What is that one? All right, yeah. Test the selection key there. Yes, and so on. So it's various ways of interacting with menus, for example, or assess that a view is not displayed. And here we have the nice gotcha. So one of the things that I want to highlight quite explicitly is very important when you're dealing with Espresso. So apart from the fact that you can do more. With Android, the recent Android, I think their market is Android X. That is technically Android 9 though, right? Is it? Or is it only Android 10? Maybe. It's supposedly representing 10, right? So the problem is, if you use Espresso, be consistent about your imports, right? Because you can happily combine, in theory, the import for view assertions matches, for example, with view matches as displayed, but import different paths, so basically different packages. You could import android.test Espresso or android.x.test Espresso. If you mix them, things will fall over. It will tell you something like, I couldn't find the instrumentation, because it doesn't know anymore which Android version you kind of want to emulate anymore, and things fall over. So first thing, if Espresso doesn't work and gives you weird errors, check that your imports are consistent. So that's a big gotcha that I fell over quite a bit. For now, I'm sticking to the old one. So android.test for your imports, basically, just to bear that in mind in case you want to go down that route. But anyway, so it's a lot more resources for different purposes, because all that is to some extent UI related, right? We have Espresso Core, which is the basic stuff. Here we have web related stuff, dealing with background jobs. So when you deal with concurrency, you need to wait and so on. Then you can invoke that as well. That you can ensure that you get the timing right. Contributions, that's kind of the additional functionality has been introduced, like recycler views that you've heard about, date pickers and things like this. Things about dealing with intents, and I think probably multi-process functionality. Yeah, so presumably dealing with activities that run across different processes. I haven't looked at that. So anyway, so it's quite a lot of course, right? Because as soon as you say UI, it's kind of everything. So bear in mind, that was really simple baseline functionality contained in Espresso core. If you want to move beyond this, it becomes a bit more tasking, of course. So let's see. I just want to show you the imports that I used to just give an impression. So the imports, of course, we talked a bit about build scripts. So the project-specific dependencies are specified in the module, right? So that's the module that's Android-specific. This is generic Gradle project, and it has one module. It basically applies the plugin Android, meaning everything Android-related must be in here. So looking at dependencies, you see now, I briefly talked about different types of dependencies. So we have implementation dependencies, and we have test implementation dependency. We have Android test implementation dependencies. So it's kind of a mouthful. What's the difference between those? Is anyone? We didn't talk about all of those. Just see. Yep.
Where they're needed in the build pipeline?
That's correct, right? So do you know which ones are needed where?
Implementation is for your main app, right?
Yep.
And then the test implementation is for the pure JVM test.
That's correct.
The other one is for the Android, the test that require Android.
Yeah, that's correct. So the rest is for the instrumentation test. So that's also good gotcha. Sometimes you are having the right dependency, but you have the wrong prefix, right? You're suggesting that, for example, that a particular library is only used for test implementation, but forget that it's actually used for the Android test implementation, which is the instrumentation test, right? So where you basically need to have a full Android environment, so UI tests and stuff like this. So bear that in mind. You have those three primitives there that you get them right. So, but you see what's actually involved, right? You load Espresso core, for example, here, certain test rules in the test runner that are necessary, and as a baseline for any testing, we have here JUnit that's involved as well. So that's the dependencies that have been used here. If you use any of the advanced functionality, you of course need to have the corresponding dependencies installed as well. Okay, so some of those. Right, yeah, just example for special cases I just wanted to point to. So if you have a spinner, you can identify spinner by ID and perform certain clicks. Yeah, if you want to select data that is of type string and is in a selection text, then you can perform a click. So you have certain conditions. So it's an example how you can nest different functionality, right? So you see that in this DSL you can, that's basically equals, is instance of check that all data that you have are an instance of string class. And the one that equals the selection test that has been specified before, then perform a click. So that's kind of roughly how it works. So it's incredibly, intricate nesting that you can do with different language primitives that are available, right? So, okay, action bar, menus, and so on. So again, it boils down to the different recipes. It becomes quite complex when you deal with the advanced widgets in the environment. Okay. Mini intermediate summary. So JUnit standard test, Mockito, Mox. Roboelectric, didn't talk about it. It's kind of virtualizing the UI test. If you want to automate this, for example, for a large number of tests, or how it's technically done, I think in the Firebase lab at Google, so the one I talked about briefly before, where you submit your app and they test it on all different phones for you, they fundamentally use this to instantiate multiple tests across the device. Think about a robot kind of thing, but it fundamentally relies on Espresso as an underlying framework again, right? So Espresso is this thing about testing the UI framework as well. Yeah, and Roboelectric can to some extent virtualize the UI test, so you don't necessarily need to have an emulator or physical device. So it provides a complete virtual environment to emulate UI tests. But again, that challenges the usability across different devices, because in the end, most important thing is to test it on a realistic device, especially UI-related stuff. More important than unit tests per se. Okay, mouthful here. So, right, cool. So you kind of have a basic overview of testing in Android, what you can do, and now we could do a bit of an outlook what goes beyond the standard approach of testing again. You guys have been, I don't know, asked, if not forced, to think in terms of test-driven development, right, in the past, right? So basically, everyone heard this in first year, right? Please. Collective nodding, that's cool. You guys heard this as well? Testing standard stuff, right? So yeah, the test should fail You implement functionality, and then you iterate, you run the tests, and then you implement a new test, and for the next round of functionality, roughly that interaction pattern. No big deal. So I don't need to waste time on this one. Few rules of thumbs for test writing, of course. Side effects should be minimized, right? If you have side effects of one test, should not affect another test, of course. That's why we have the before and after, or the setup and tear down methods, so we can clean up before and after, respectively, our tests. It's important to not rely on side effects of previous tests. For example, if you rely on the order of execution of tests, you most likely have an issue with the test because JUnit randomizes the execution. So if you run multiple times, you should get a solid assessment whether you have side effects or not, if that's an issue. For example, you want to add an entry to the database and then use it in a different test. Well, that's not supposed to happen in the test itself. That's supposed to happen in the before and after setup and tear down method, of course, as well, right? So that's the idea. So make everything independent as possible. Cool. Advantages of TDD. What's the advantage of TDD? You guys need to know that. Why do we do test-driven development? Yep, please.
You'll make sure that all your code is tested from the beginning.
Cool. That's cool. Yep. So it guarantees full code coverage. Yep. Test coverage. Sorry. You were slightly before that. So Victor first, and then you.
Well, when you if you write your code before you write the tests, sometimes you write the tests kind of to succeed because you kind of think you kind of know how it's supposed to work, and if you write the test first, you're not as biased.
Yeah.
You get a more.
Yeah. Cool.
I was actually about to say exactly the same thing as he was.
Yeah, but you probably would have used different words.
Yes.
Good. So that's what, yeah, exactly. That's right. So you avoid bias and you have full code coverage. Any other points? Good side effects, perhaps, of doing TDD?
You'll know when something breaks in the future. If you make a change to your code, then the test suddenly fails, you suddenly know you broke something.
Cool. So, quick regression testing, right? So fast iterations. Yep. Cool. implied by the coverage. Cool. Yep. Other thoughts? Roughly it, right? So other side effects is the idea is if you think about API before implementation, right? So by writing a test, you're implicitly writing the API as well, right? So because you're writing the API of your program for testability. So, okay, how can I test this functionality in isolation? And that means you structure your API and you code accordingly as well. So it has a bit of an advantage forward-looking as well, that you have this focus, right? That leads to highly testable APIs because you always need to think as a tester, basically, right? So, and all the stuff you mentioned, of course, as well, full test coverage by definition. And the other thing also, testing as documentation, right? So I'm not sure if you, when you download an open source library and use it, what do you look for usually? Documentation, right? So cool, yep. What else? Yeah? Who of you would look into the library, look at the tests first before anything else? After you know, of course, the functionality. Did you do that ever? Sometimes? No? Okay. So I tend to do that quite often because it tells me immediately how I interact with this thing, right? So perhaps, yeah, the functionality sounds good, it's about right there, right? But instead of wasting time looking at the source code, just look at the test and see if it's actually an easily integratable API or it's incredibly complicated. Because you see the API as documentation by looking at the test, better looking at the Java docs or Doxygen output or whatever else of C++. So it's one way of thinking about it as well. So it can just be a low threshold for you to actually deal with this. Yeah. So is there any problems with TDDs? Are there any problems with TDD? Do you think there are problems? Any? Who's actually doing TDD here? Honesty. Don't worry, the camera's not pointing at you.
I'm not.
Cool. Honesty. Right.
No.
Right.
It's kind of hard knowing what to write tests for sometimes because we kind of have to have an idea.
Yeah.
Only for knowing what we should develop tests for. First, maybe for the third lab, I could try to do that, but for the first one, at least, that.
So that's one of it, right? Sometimes it's, even though you know the specs, right? It's not really clear how you approach this. And you don't want to waste time writing tests and then refactoring everything once you change your mind, right?
It can slow you down in the beginning because you're unsure where to begin. And then you want to just do brainstorming, it's hard to then test your brainstorming.
Yeah. So especially if you are into prototyping, right? So you want to, you take 3 days and just want to prototype to see how far you get, right? That's not the time where you want to test, right? That's the time where you just get your hands dirty, throw away stuff and start from scratch again, and shouldn't have minimal technical depth, right? Code is liability. The more code you write, the more you need to maintain it. Tests are also to be maintained. It's expensive, right? If you change your API, screw your tests. You kind of need to review all of them, and that's pain, right? So while writing of them may sometimes not be hard, reviewing is often way harder because you haven't looked at them for some time, and suddenly you need to get all this mindset and mode again. Yeah. That's definitely one of them. Yeah, so other points?
Yeah, I was thinking if the specifications are very clear, then it's easy to do testing development because then you know exactly what you're supposed to do.
Yeah.
So if specifications are very clear, it's easy.
Yeah.
If they're ambiguous and might change.
That's got to be harder then, right? Yeah. So yeah, that's the usual thing, right? So it's not clear where you start in the first place, what you want to test. Granularity, what goes into a single test, right? How much functionality do you test there, right? That's a bit more experience-based. But the problem is this kind of links back to those ones because you don't know how much implementation effort will be in a particular functionality that you kind of may make the wrong call and having too much, you're covering too much code without knowing it in advance, of course, in a single test. Because you write the test first and only then figure out how you actually do the implementation. Whereas you probably then, in hindsight, would say, oh, damn, I should have kind of have a much more fine-grained test or decouple that a bit more and so on, right? So, of course. Aspects also, it all goes alongside in a way, how to name the test meaningfully, right? Because do they make sense already at this stage? So very simple kind of things. And last but not least here, yeah, the user, right? So do the tests make sense to the user? So sometimes TDD is a bit, well, developer-centric in a way, right? Because you writing the tests, you writing the code, yeah? You're kind of trapping yourself a bit in this developer perspective approach, while you're trying to emulate what a good API is. Fundamentally, you're already thinking in your head how to structure the code. You're kind of on the code side of things. And that's sometimes a bit, can be confusing and come with all the pitfalls that we talked about with respect to having too much transparency and too much structural insight into the code, right? It's kind of preconceptions. So, okay. So what happened is I don't know, that quite some time ago actually, 10, 15 years ago, there was the alternative movement. Okay, TDD is fun, right? So it's good. But how can we make it in a way so that we have a bit more, how can we make tests a bit more easily understandable, right? So that the user, that guy over there, hopefully, can actually understand what's going on in the tests. So that was one of the key ideas. And the concept arriving from there was basically behavior-driven testing. So. And what are the principles? Well, it's kind of falling in line with the idea of having a certain agility. When you're doing your sprints, some of you do your bachelor thesis right now. When you're developing your sprints or planning them at least, you usually use user stories, right? So you associate story points with them and then assign them to individuals and work them off and things like this, right? And usually those, I think always the user stories are expressed in human readable language. Let's say, given this situation and doing the following thing, I expect the following to happen. Right? Very similar to what we saw just now in terms of the DSL expressions, right? From a technical perspective, but now more from a human perspective. That's how we specify user stories. And why do we do this? Why do we have user stories in a very human readable, explicit way?
To make it more available, not just for developers, and to have the customer more involved directly.
Exactly, right? So the whole Agile process ranges around the idea that the product owner has access as well, right? So that they interacts with the developers directly in a way, right? And for this purpose, it's of course more than sensible, especially if you want to do it Agile, to inject new user stories from the product owner, flexibly and easily. If everyone speaks the same language, roughly, then it of course makes it very easy to test against requirements, for example, when you actually delivered. But of course, it also kind of ties the link between the technical perspective and the non-technical perspective a bit more. Right? So the idea of BDD does that. So writing tests in an omnipresent language often like natural language English, for example, with a kind of clear structure. We get to that one, which is accessible to everyone. In principle, allows even third parties to specify tests in a human readable form, and can ideally, of course, be executed automatically as well. Right? So we don't want to give up or actually sacrifice the automated execution capabilities, but actually just facilitate this interaction a bit more. So basically, this is kind of wraps it up quite nicely. I found this on the web, but it's kind of shows our different ways of thinking, right? So here's the client saying, well, we would like to encourage new users to buy in our shop and so on. We offer a 10% discount, right? The dev's already thinking about the implementation, right? It's having the methods in mind, how they can do it. This guy is thinking about the API that's associated with this, right? So, this guy is actually thinking about the testing that's associated with this, right? So from a UI perspective, go to search catalog, enter something, click, 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 and then verify that's actually what it is. Something we just saw now, basically, in the context of UI testing, right? And the idea is there, can we rephrase testing in this kind of way? That we, instead of saying, thinking about our different domains as implementer and tester, for example, for QA purposes, well, can we do it this way? Given that the user has not ordered yet, so again, the persons we encourage to have new users buy in our shop. When the user adds a book with a price of so and so many euros and so on into the shopping cart, then the subtotal is 33.75. So it's a very clear outcome-centric perspective, right? So it implies the 10% discount, and it focuses on the user, the conditions, the expectations, and the outcomes of the actions, right? So what we expect to come out of it. So fairly similar to the mocking that we just saw before. And that's the thing. So it's behavior-driven testing. So let's rethink how we write tests in terms of conditions, actions, and expectations or outcomes in the end, right? So here, example. As a role, particular role, administrator, user, client, you name it, right? I want a particular feature so that have a certain effect or benefit in this case, but I think effect is probably a better term. It's that something particular happened, right? So, and this would allow you to basically specify acceptance scenarios for the acceptance tests with the customer to ensure that, you know, to tie the link to validation, that is actually what they want to do. Can you specify those tests in this very way? Given that we have a given context, when in this context a particular event occurs, then ensure that we have a particular outcome. Can we guarantee this outcome? Yeah? And that's really nice, because suddenly we have a language that's, of course, human accessible. It's still algorithmic in the expression, in a way, very clear. And, of course, makes it very user accessible, right? So simple. As a user, I want to be able to enter my credentials so the system logs me in after confirming the selection, right? So in a test scenario, it would be, given that I'm a user, when I enter my credentials and confirm, I am logged into the system, the effect. Right? Not necessarily a benefit or whatever else, but that's the outcome, right? Perhaps more specifically, one could, the environmental condition could be better characterized by indicating that user is not logged in yet, right? Given that I'm a user, I'm not logged in the system. When I enter my credentials and confirm, I'm logged into the system, because that would be more comprehensively capturing the environmental context. So, yes. So and that's roughly the idea, that we have a way of specifying this. And of course, where there are ideas, there are certain forms of implementation that have tried out and explored that to some extent. It may take me a bit longer than, I don't know. Should I do it now, or should I leave it to tomorrow morning? What do you guys think? To go through that, some examples for that. Yeah, now is good. Let's do now. Cool. So, because it may take me a bit. So, yeah, for example, you do behavior-driven testing. You have a login interface as an example here. Simplify. How can you actually do that? Right. So, of course, we need frameworks. Who hasn't expected that, right? So one of the frameworks that is commonly used for that purpose is called Cucumber. It's open source again, one of those ones. Always funny names involved. That allows you basically to do behavior-driven testing by having the executable specification. And it follows exactly that kind of pattern. Given something is a certain environmental state is happening, and there's a certain action performed, then I expect a certain outcome. So Cucumber is market leader. Has bindings for a large number of languages, Java, of course, as well, but also C++ and others. So you can download it, you can modify it. There's support available for it. Worthwhile having a look into. And in addition to the framework, which manages the runtime execution, there's, of course, an associated language, right? So again, it's a kind of a domain-specific language in a way. It's a specification language that allows you to specify exactly those statements here as they're shown. And Gherkin is the standard for that one pretty much, because it's also used in different BDD frameworks. So if you use that language for specification, you kind of get a hang on. And I actually have examples there. You get a reusable test scenario, ideally, right? So, but of course, the devil is in the detail, and with every abstraction level that we introduced here, right now, coming from unit testing through Mockito, through Espresso, there's of course another level of abstraction here. So the idea is here. That's the Gherkin language, right? Usually specified in .feature files. If you find those files, it means nothing else. That most likely someone does some BDD in this particular project, and it's basically a contains of a feature. There are certain other keywords, but the main ones are basically a feature that describes the scenario, right? So you can identify a scenario, and then a given term, given particular preconditions. When event or trigger happens, then have the expected output. Exactly that. That's it. Right? So, and for organizational purposes, there are other concepts that are involved. So generally, we have one feature per file. There can be a background specification that needs to be set up. So if you think about the setup method in JUnit, for example, you need to connect to a database or things like that. If you have those general functionality that's done in the background, then you can have multiple scenarios. So you use the same feature from different perspectives. Think about it, use cases, perhaps, right, as one way. And then you have the given, when, then, and so on. And you can combine within those different statement levels. You can combine different conditions. For example, of course, you can have multiple preconditions. You can have multiple events or triggers that need to co-occur in order for this test to trigger, and so on. And also multiple outcomes that you can specify. So those are kind of some of the ideas there. Right, and the fundamental components are basically, well, you have an application that's to be tested, generally UI, right? So then you have a runner. This is kind of a specification of meta information. It set up the instrumentation, very specific to the framework, that is used for the test. Also specifics about the Android operating system. The robot is instantiated. The robot is the guy that is actually running through your code and actually testing stuff or pressing buttons and so on. You'll see how that works in a second. And then you have the files that specify the features, for example, right? So this is a typical setup of the code structure there. So here we have a certain functionality. So we have the login robot, the runner specification, the different steps that are executed, some tear down functionality, and here down here in the assets are the actual feature specifications of what one expects the individual aspects to do. So the what individual tasks you expect the system to do. And I just want to see if I think I have a runnable example that hopefully. And I want to start with the dependencies actually, because they are kind of insightful to see what actually is all involved. It's kind of a handful that you actually need to have. So right. So you have the cucumber implementation that you attach to it. You have Espresso involved, no Mockito, so there's no mocking happening here. What else? Right, there's a specification of the test instrumentation runner. So because you're using instrumentation that goes beyond the standard instrumentation of Android, you need to indicate and specify that as well. So you need to indicate the instrumentation runner. Where is it? Are they down here? So this is basically run in order to execute the test, so the environment to be set up. So instrumentation is generally the thing that's basically the Android environment. And here it's about instantiating the this cucumber environment, the instrumentation core, set up some initial parameters down here. So, but most importantly, actually, it instantiates the instrumentation and basically runs, and at the end, yeah. So basically, that's the idea, that it basically just starts the instrumentation, so the BDD process can actually work. Cool. So right. So let's look a bit at this application that we're dealing with. Just I think it's always sensible to start from that perspective to see what we expect as input and output. And what has been done. So it's also well, with some modification now working project from web. So I have a link to that one as well. So it's quite a neat demo of how the BDD works. Be sure to invest some time to set up your system, because you need to do some Gradle updates and some library updates and so on, because there's a lot of dependencies that come along with this. Hang on. So fundamentally what it shows, or supposed to show, is basically a login screen and the ability to sign up. So it's basically a very sign up system of whatever real nature. But I just want to give you a feel of what it does. It may not have been a clever idea to do that in my system. So, well, anyway, what's fundamentally happened as long as it doesn't come up? So basically, it's a login activity, and it has an email input field. It has a password input field, so edit text, and it has a button, of course, that needs to be mapped as well. So a submit button, and when you press the submit button, guess what? It validates the fields. Does it actually make sense what you entered? And then validates the account, right? So if there's no error from either the email edit or the password edit, then validate the entire account. So that's roughly how it goes. Not much magic there. If you press the not submit but the sign up button, then an intent is created, and this intent carries in, points to login activity and sign up activity. Sorry, from login activity points to the sign up activity. So basically says, hey, sign me up. And has some flags with respect to the execution that determine the execution of the activity, and basically starts that intent. So that's roughly it. Here's the validation. It just basically checks if their stuff has been added and entered in the corresponding fields. So, and how that looks like this roughly, right? So you have an email login, password, and we have the sign up functionality. Quite professional. Cool. Sign up activity, of course, in analogy allows you basically to do some sign up functionality. So we saw the instrumentation here, so that's basically the environment that's set up. Right, so now it becomes interesting. So if you look at the features down here, let's look at login first. This is written in Gherkin, right? So it's the .feature file. Everyone sees that, right? It's cool. And on top it describes the feature that I actually discussed. Perform login and email and password inputted, whatever, right? So that is just human readable version of what is actually happening there. If you then look at the feature, you have the tag login feature, so it basically is tagged already, and it says the scenario is the scenario outlined above, and then it's actually breaking down what individual steps and preconditions are or have to be met to actually facilitate this, and that's the idea here. So given that I'm on lock screen, right, when I input email has the link to this particular table here. Which is basically a kind of CSV kind of approach. So it basically can use those different entries in the corresponding columns, right? So here, email, password, and view. If I input a given password, again borrowed from the table down here, and I press submit button, I should see the error on the view, right? So this one tests actually 4 errors, right? For example, go further down. So this is a login feature, but this time with a slightly different scenario outcome. The input, email, and password are entered in a correct format, right? So same here. So when I enter my email and password, I should see an authentication error, right? So should so it should see authentication error either true or false. So in some cases you should, and in some cases you shouldn't. Cool. And the other one here is the login feature. The last scenario would be when I'm on the login screen, I tap the sign up button. I should end up in the sign up screen. Straightforward, right? Okay. How's the system now figuring out that stuff, right? How is the system determining the activity? That's quite human readable, right? Quite straightforward. A bit syntactically oriented. Well, even though it looks really beautiful, it kind of breaks down to something a bit like this. Because fundamentally, what you will need to do then, and here's the magic and the pain. Well, here's the mapping. So the mapping is largely done via annotations. And how you bind two things together, meaning the technical operation in the system and the user description, is using those steps specifications, right? So you have, for example, a before annotation that refers to the login feature. So before executing login feature, run this before, right? So, and what does it do? It creates an intent and instantiates some activity. Not too interesting right now. After, how to tear down the entire thing, it basically finishes the activity, tears down the activity. So that's fine. Okay. More interesting here, right? So if in any of the features you see the use of given I'm on the log-on screen, so given is a fixed annotation, and I'm on a log-on screen is the value there, then do the following, right? So there's then a method called I'm on login screen, assert not null activity. So the activity is not null. That's basically what you're doing. An activity is a reference to, if I get it right, will be the login activity. Yeah, there you go. Login. So activity test rule, get activity, provides you an instance of login activity. So checks that you actually have the login activity active. That's basically what it does, right? So when I input email has this placeholder here. It says, well, you know, pick the view identified with email and perform the following task. Well, enter. This is kind of this placeholder here maps into the first argument here. Types the following text into that particular field. Which framework is this one here on Vue?
Espresso.
It's Espresso, right? So now we're actually linking it back to Espresso, how to do stuff. And I think you gather the pattern here, what's happening, right? So for each of the individual statements that we saw previously, we kind of still need to encode what's actually happening doing, right? When I press the button, submit button, well, what's happening? You match the submit button and you perform a click on it, right? So you still need to model the individual interactions or actions in the UI manually using Espresso, but this now helps you to understand what's actually going on there. And but somehow map this into this behavior-driven world. And then in this ideal case, so for example, here's an alternative representation. It's kind of a bit of a cheap regex, if you like. So it shows you a alternatives. I should see true, false, auth errors, right? So it basically figures it out and checks what it actually represents. So Boolean should see error, and it matches whether the error is displayed or not, whatever. So that's the thing here. So and the same for the sign up activity. Again, there's different feature, different file, therefore, same pattern. Everything that's used in the feature specification needs to be reflected here, right, with the corresponding annotation. That's the key idea here. And that's basically how this whole thing works. So let's see if we can run this thing. Perhaps we'll even see something happening. Seems like everything fails. That's good. Very promising. Hang on. It's probably something about something not being started or not being compatible. Give me a second. Perhaps I quickly figured out, else we leave it at that. What does it say? A target context. No instrumentation registered. Ah, that's beautiful. Let's see if I can use the other emulator. Perhaps that works better. Come on. try the feature login. It should prompt me for the emulator. It doesn't for whatever reason right now. Anyway, so it doesn't quite do. Perhaps I'll figure it out and show it afterwards. But that's the essence, basically. So that you basically have your individual features, and then it basically says you where it fails, in which scenario, and which particular statement, right? So, and ideally that's extremely user readable because you know exactly which condition is not met under, in doing the execution and so on. So that's the last one. So that's BDD as a way of actually mapping user perspective on tests. Who's keen trying that out for their project? Am I the only one sensing excitement here? I guess I am. I don't blame you. It is kind of a pain, of course, and so that's the demo I used there. And to some extent, it's kind of just adding abstraction after abstraction, right? So you saw that we're building up abstraction where possible. Every frame will coming after the next one, and I think pruning the tree, I think Espresso is probably about sensible for us, right? Because that covers the ground in terms of the Android testing pyramid. We have unit tests, we have integration tests, there's Mockito kind of stuff, and of course on the top level then UI tests. But this whole behavior-driven thing, this was more like an awareness exercise, right? You know what BDD stands for, what it means, and if the trend comes back, eventually, I mean it's still there, then you know how to possibly attack it, what to look for it. But in the end, it kind of just means more work for the developer, because in the end, you're still translating the human readable stuff into code specifications anyway. Right? That's pretty much, you kind of need to map this string against Espresso expressions, which are then, hopefully flexibly executed. But yeah, so that's the question, if it's cheap enough to allow this, or if it's a project that really requires it. Other than that, you're probably better off writing tests that are kind of make sense when you explain the test to the user, with some sanity, I guess. So, but anyway, just to give you some insight, if you want to read up more about behavior-driven stuff, there's some links here, a good article as well. I have linked Cucumber here, that's right. And if you want to look up Mockito, Espresso, of course, the links are provided there as well. Espresso is kind of the native Android thing. Mockito stands in its own right, Cucumber as well. So have a look at it if you can, or if you want to, it's quite worthwhile. How many of you are going to write tests in your project? Okay. Yes, okay. Yeah, commit early. That's a good idea. So yeah, test-driven development. Yes, I'm committing. See how many you actually do in the end. But yeah, thank you for your time and attention. I hope you took something away from it. So.